building off of RSA encryption is elliptic curve cryptography. And so we're going to use an elliptic curve on a graph here. And so the formula that I'm going to be using for a basic elliptic curve is that. But that we're not going to be really paying that much attention to that. We're just going to draw a pretty standard elliptic curve. That looks something along these lines. Now, one of the key features is that it's symmetrical over the x-axis, so everything above is the same as below. And when we use this, we still have a person who generates a point, just like before with a signature. And so the point will be anywhere on the elliptic curve, and we're going to just call that G. Now, the standard practice for this is to double G, and another way to call that is to dot G. And what you do is you take a tangential line to wherever G is on this elliptic curve, which will intercept the curve no more than 3 times. At the first one, we'll call that negative 2G. And in order to find that, we use the symmetric nature of this elliptic curve, and we go all the way down to the opposite side. And that gives us 2G. Now we've dotted it once. In order to find 3G, we do the exact same process again. This can be done in an infinite amount of times. So the 3 or the 2 or the 1 is the variable, that's n. You can do that any number of times. If you know what n is, it's very easy to follow the math and find where that final point is. Unfortunately, whenever you don't know what n is, it's almost impossible to find how many times you've dotted on this elliptic curve to get to that point. And that's where the power of elliptic curve cryptography comes in for encryption.